Going to study about binary adders. Okay, we have done the addition of single bits. Okay, single bit, a binary number that has only single bit. What about binary number with multiple bits? Okay, for example, let that be 1 plus 1. We have studied about that. What about 1 1, 1 0, 1 1, or even 101? What about all those calculations? So we're going to study about that. We're going to study about that, how we're going to implement that. Now binary adder is of two types. One would be your ripple carry adder. This is one type, and the next one would be adder with a carry look ahead. Okay, carry with a carry look ahead generator. This is the second type that we have. Okay, so you see this is an example of this. You have let that be your first binary number is a of I, which is a 4-bit binary number. It has 4 bit, and b of I, let that be, that is also a 4-bit binary number. Okay, so we're going to name that as a0, a1, a2 and a3, b0, b1, b2 and b3. What about the addition of these two numbers? You have let that be your first bit calculation. Let that be that has a carry of c0, which is obviously going to be 0. Okay, for first bit calculation obviously there is no carry. Okay, for normal calculations. So the summation of these two is going to be s0, and the carry from that bit calculation is going to be a c of 1. Okay, so carry from that bit calculation is going to be c of 1. Okay, so the next bit calculation, the summation is s1, and obviously we have to use a full adder here to implement this 3-bit addition. Here we can use full adder with the carry being 0, or we can simply use a half adder for saving of the resources. Okay, the very same way we have to use full adder here and also full adder here. Okay, from this bit calculation you're going to get the final bit calculation. You may get a c4, that is a final carry that will get back to your result. So your summation would be s0, s1, s2 and s3 with c4 as a separate carry, and the summation is going to be termed as s of I. Okay, now c4 comes whenever there is an overflow. For a 4-bit calculation, there happens to be a 5-bit solution if there is an overflow. If there is no overflow, then we might get a 4-bit solution. Okay, there is no problem with that. The c4 is going to be 0. But that is simple. Overflow case, you will find a c4. Okay. So how we're going to implement that? We're going to follow the first method, that is a ripple carry adder. Okay. You can relate this. You can relate this with the explanation that just I did for the first bit calculation. Okay, this is for the first bit calculation. Or you can numerically we are going to represent that as 0. We can use a full adder, but we can also use half adder here because c0 is 0. But I have used full adder here for the first bit calculation. c0 is there, a0 and b0 is there, and the summation is given as s0, and there is a carry output which is going to be fed to the next full adder, which will implement the next bit calculation. From there you would get the summation s of 1 and also a carry that would be fed to the next one, and from there you will find s2 and there would be a carry that would be fed to the next full adder, and thereby you will find s3 and a carry if there exists an overflow. Okay, so thereby you will find the summation s of I. Now why we call it as a ripple carry adder? Okay, this one is a ripple carry adder. We call it because for the sequential, if you see the addition procedure is sequential, the operation of this full adder cannot be completed if the operation of this full adder is not completed. Okay, because after the completion of this full adder operation you will get the c1 which would be fed to this full adder, which will then operate, and this will then feed the full adder to the next level, which will be then operated, and then it will feed the full adder of the next bit calculation. So there is a ripple operation here. Okay, the operation of the subsequent stages are dependent on the operation of the first stages. There is no instantaneous operation. It will take longer time to operate. It will take longer time to give you the final result, that is c of I, s of I. Okay, so that's why we call it a ripple carry adder. Okay, so there is a ripple of the carry. Okay, to stop now this has a problem of longer time of implementation. For shorter bit calculation, like for 3-bit calculation or 2-bit calculation or 4-bit or even 5-bit calculation, that is okay. But what about suppose that there is a binary number with 100 bits? So that's going to be a longer time implementation for the operation. So to solve that, we have to use the second type of binary adder, that is adder with carry look ahead generation. Okay, so that we will discuss now.